Today we want to look at our next topic, which is control structures. Before we do that, let me just go through this with you. LMS. Last week, we had the second attempt for the quiz. Okay, so uploaded some documents, most of which has to do with some images to give you a picture of whatever we are doing. This is an image of various types of programming languages. I'm sure some of you have more questions, and this image will clarify some of the questions that you have. Christian, do you have a question?
Yes, sir. Please, we forgot to pray.
Oh, I've prayed already. King,
Yes, sir. Please, I can't see the screen.
then it's from your end.
Okay.
Check it. All right, so like I was saying, these images here talks briefly about programming languages, high-level language. There are languages that are scripting language, others are functional language, and all that. And it gives examples. And here too, talking about some top companies and some of the programming languages they use. And then when you come all the way down, you see control structures. So this is based on what we are going to do today. So mainly the images here talks about the loops, the looping control structures. So we have the for loop one and then do one. The images explaining the concepts which we are going to look at today. Then we have here functions, which is our next topic. And hopefully next week, meet face to face. Then we look at function. But there's a project here I would like you all to review before our meeting next week. So project we are going to look at, and also it has to do with the exams. The exams or part of the exams is going to follow a similar structure. Okay, so next week, our face-to-face meeting, we'll look at this project, how to do about it. So please visit the LMS. Have a look at files. So let's look at today's lecture. Today we want to look at control structures. Okay. Our second lesson where we talked about algorithms, we looked at the three main control structures, or the three types of control structures. We talked about the first one, which has to do with sequence. Okay, so we said with a sequence, this type of structure has to do with placing statements or executing statements one after the other from top or from the up to the down. It's starting from the top to the down. Okay. So most of the examples that we've seen so far, most of the examples we've seen so far, we are going to, or were based on the sequential approach. Okay. Please, before we continue, this individual here, Malian Gaza, rename yourself, join the class. So I'm going to take you off. And be mindful of comments that you post in the chat. When you come to the chat and you post a comment like what they go on for here, rename yourself and join. So I'm taking you off. Please, when you join the Zoom session, be mindful of comments you make. I've always asked you to rename yourself. This is your full name, your ID, and type your name in the chat, name and index number in the chat as a form of attendance. All right. So we've been talking about the 3 types of control structures. We have the sequence, which, like I said, are the programs that we've written so far. They are in a sequential format. And also we looked at those type of algorithms as well. So today we want to go further and look at the branching and then the loops. Okay. So we said the branching, they are control structures in which you have a condition and a statement is executed if a condition is met. Okay, so it says, according to the condition, a decision of either true or false succeeds. If the case, in the case of a true decision, then it performs a certain statement, certain task. Else, if it is false, it performs the alternative statement or the alternative task. So that is how the loops work. Sorry, the branching statements work, which we also call the conditional statements or selection statements. And then we have the loops. Okay. Loops are more of repetition. Okay, so these types of control structures allow a statement to be executed repeatedly. Okay, so a certain loop condition is satisfied, or while the condition is satisfied, the loops or the program continues to loop or repeat itself. All right, so let's look at some algorithms that fall under this type of the looping or the branching conditional statement. So first we'll start with the branching conditional statement, then we'll come to the loops. We'll start with the branching or the conditional control structures, which has to do with the use of true or false statements. Okay. And then we'll come back to look at come back and look at the loops. We'll try one example on it and then come back and then look at loops. But before that, there's this image. I think when you go to chapter 6, you'll find it there. So there's this image on control structures. If you look at this one, the middle one carefully, so this image here has to do with the branching control structure. Okay. Now the branching, also known as the conditional selection or the decision-making control structure. First and foremost, it takes a decision. So we know the decision symbol here. It takes a decision. Now the decision can be maybe maybe there's a question which is looking at whether a student has passed or failed. Okay, so this statement would be, I'll make this maybe pass if it is true, then pass if it is false, then we'll say fail. Okay, fail. Now, the decision parts will have a condition. Okay, so we know that if a student writes an exams, okay, so let's say C++ exams, okay, and then the student is given some score or the marks the student scores in exams. So let's represent that marks by the variable x. Okay, C++ mark in exam by variable x. Now, when we come to the decision, we are going to say that if the x value, okay, is greater than or equal to 50, that is the condition. The condition here is that the x, which is the value the marks the student had, is greater than or equal to 50. Then it should perform the following task. Okay. Now, if it is greater than or equal to 50, that is, if it is true, it should do what? It should tell us the student has passed. Okay. But if the value of x is not greater than or equal to 50, that will give us the false response. Okay. Meaning that what? The student has failed. Please, are you all following?
Yes, sir.
Yes, sir.
Okay.
Yes, please.
So the branching conditional statement, they execute a task if the condition is met. Okay, so as we can see here, there is a condition, and the condition is that the student's mark should be what? Greater than or equal to 50. Okay, so if the student is scoring 49% in exams, that 49, is it greater than or equal to 50? Okay, we all know by observation that the 49 is what? Less than 50. So that will be a false response. So it's going to give us what? Print out the statement false. So that is how the branching conditions or the branching control structure works. Okay. So now let's go back and look at the algorithms, or example of problems that will require the use of the conditional control structure. So when we go to page 14 for our lecture notes, you see an algorithm there which says an algorithm and a flow chart to find the smallest of two numbers. Okay, so we have two numbers, number 1 and number 2. We want to find the smallest of these two numbers. Okay, in this case, we don't know the value of the numbers. We don't know the values. Okay, the values are not known, and that's how algorithms are. You don't know the value, so you write it such that when you now have the value, or when the values are entered, the algorithm should be able to make that decision. Okay. So if you look at the algorithm carefully, or from previous lectures we've had on algorithms, what you do is you need to find what are your input variables. Your variables, what are you? Sorry, hello, can you all hear me?
Yes, sir.
Yes,
Yes, sir.
yes, sir.
So
Yes,
my
sir.
internet went off. Wow. So I was talking about the algorithms, okay, and the fact that anytime you have an algorithm, you first look at what your variables are, okay, starting with your input variables. What are your inputs? Okay. So if you look at it carefully, the inputs are the two numbers. So number one, so I'll just say N1 and N2, number one and number two. But here is the case, we don't know the values for number one and number two. Okay. Now, the problem here is that we need to find out the smallest of these two numbers. So if you want to find the smallest of these two numbers, okay, number one and number two, that means that either number one is greater than number two, or number two is greater than number one. Okay, so that's the scenario. Either number one is greater than number two, or number two is greater than number one. Okay, so we have a decision here. We have to make a decision. We have to make a decision. Okay, so problems that come in this form are example of what we call the branching or the conditional or the decision making or the selection control structures. Okay, they come in for you to make a decision. Now, this decision will give a response of either true or false. Likewise, what we have here, either true or false. Okay, and depending on the response you get, it's going to execute one of the tasks. Okay. So let's look at the algorithm. It says first, you start step one, then step two, you input the two numbers. That's one, and then what? The number two. Okay. Then here we have the condition. Okay, so step three is where the condition comes in. So it says if, so I'll just put the condition in the brackets. If number one is less than number two, can you all see that? If number one is less than number two. So this is where we make the decision. Or what we also call the condition. That's the condition. If number one is less than number two, so whatever we entered as number one and number two, if one is less than number two, okay, so we want to get the smallest. So if one is less than two, then what do we say? Number one is the smallest. Else or otherwise. Else or otherwise. So you can see that there are two decisions to be made here. So if it's not N1, then it's what? If it's not number one, then it's number two. Okay. So otherwise it's what? Number two, or the smallest is number two. We end the if and then we stop. Okay. So this is an example of the or this one example of the branching or the conditional control structures. Okay. So if we come into the flow chart, you can see here the start, which is linked to this. Then you input the numbers. So input number 1, then input number 2, value of number 2. Okay. Then here we make the decision. Here we are making the decision. Okay. The decision. So is number 1 less than number 2? If it is yes, yes in the sense of being true, okay, then we'll say print the smallest is number 1. If number 1 is not less than number 2, which is no, 0, or false, then we say print out number 2, and then end the problem, or stop. Are we all with me?
Yes, sir.
Yes, sir.
Yes, please.
Yes, sir.
So this is how the branching or the conditional control structures works. Okay, so we'll try and implement, or we'll write this program so that you have an idea of how it works. Okay, so in the terms of the algorithms, you do not write the value. So in terms, you are trying to solve this problem, you don't go and say the value of 2 is, the value of number 1 is 2, the value of number 2 is false. No. Okay. Rather, you use variables to represent the values, so that when you start implementing it, you prompt the user to now enter the values of 1 and 2. Then it will use that to do the computation. Please stop writing on the screen. Person with the name Zoom user, rename yourself, else I'll put you in the waiting room. Stop writing on the screen. All right. So that is the how the conditional control structures work, or the decision making of branching control structures work. Let's see if we can look at another example. Then we'll try go into chapter 6. All right. I think I like this example. So the example here, similar to the one we just saw. All right. So similar to the example we just saw, we want to look at another example here. So in this example, we are looking at, the first one was the smallest of 2 numbers. This time we are looking at the largest of 3 numbers. The largest of 3 numbers. So we are looking at the largest of 3 numbers. Okay. So the largest of 3 numbers, that's to say our inputs are number 1, number 2, number 3. Someone can also decide to use X, Y, and Z as the inputs. 3 numbers. So what does this say, or what would this mean? How would you solve a problem like this? Okay, you don't know the values of the 3 numbers. You don't know the values. So how will you go about it? So first, we'll say that the first number Okay. If the first number is greater than the second number, we want the largest. Okay, that's what we want. We want the largest. So our focus is on the larger number. Okay. So if N1, number 1 is greater than number 2, then our answer will now be what? We are going to print out number 1. Okay. Because number 1 is now greater. So it's the largest. Okay. Then now we come and compare number 1 to number 2. So we say number 1, sorry, to number 3. It's number 1 greater than number 3. Okay. If number 1 is greater than number 3, we print out number 1. Else, number 3 is the greatest. Are you all with me?
Yes, sir.
No, sir.
Okay. Now, in the first instance, or the first condition, if number 1 is less than number 2, if number 1 is not greater than number 2, then that means that what? Number 2 will now be the greatest or the larger of number 1 and 2. Then we'll rather come and compare number 2 to number 3. Okay, so we have 3 numbers, or let's just take it as 3 individuals. We want to see who is the tallest. So we'll compare the first person to the second. If the first person is taller than the second person, we take the second person out and then compare the first person to the third person to see who is the tallest. Okay, but if it happens that in the first comparison, the second person is taller than the first person, then the first person is out, and then you compare the second person with the third person. Okay, so it's a similar approach. You have 3 numbers, you compare them. Okay, take the first 2, compare it, the one which is the tallest or the longest, you pick that one and compare it with the next one. Okay, so that's how the algorithm is going to work. Okay, so let's look at the algorithm. In fact, there are 2 of them. Okay, example 9 has 2 different algorithms. So if you have your lecture notes, you can flow with me. So the first, we start, then we declare the variables, okay, that we are going to use, number 1, number 2, and number 3. Okay, so now it says, if number 1 is greater than number 2, can you all see it? If number 1 is greater than number 2, okay, that means that if this statement is true, that number 1 is greater than number 2, then go to step 5. Now, what is step 5? Step 5 is here. Okay, and what is step 5 saying? Step 5 is saying that now come and compare number 1 and number 3. Okay, because at this point, number 1 is the greatest or is greater. So we take number 1, and then now we come and compare that number 1 and number 3. So is 1 greater than 3? If 1 is greater than 3, then we should print what? Number 1 is the largest. Else number 3 is the largest. Okay, so if number 1 is greater, we jump all the way to what? Step 5. Now look at the other scenario. Now the other scenario is when this condition happens to be false. Okay, so if it's false, that means that number 2 is the greatest. Okay, so if number 2 is the greatest, then we move to what? Step 4. Now, step 4 is saying that we have to compare number 2 and number 3. So is 2 greater than 3? If 2 is greater than 3, then we say 2 is the largest, else 3 is the largest. Okay, so we are comparing 3 numbers. We want to see the largest among them. However, we take them one. Okay, you take the first to compare, get the largest, and then compare the largest to the third number. Once you are done, you can see here from step 4, it goes all the way to what? Step 6. You don't have to do step 2. You don't have to do step 5 because step 5 was looking at when 1 is greater, when number 1 is greater. Okay, so now let's look at the flow chart. So the flow chart, we have the start, then we input the numbers using the input symbol. Then you can see here that we have 3 decision-making symbols here. 3 of them. Okay, so we have the first one, the second one, the third one. So just look at the flow. So the first one has to do with our first condition here. It's number 1 greater than number 2. So it's 1 greater than number 2. If it is yes, then it will now compare number 1 and number 3. Okay. So if it compares number 1 and number 3 and number 1 is still greater, then it prints out number 1. But if number 3 is greater, then it goes out here and then prints out number 3. Okay. Then that is the first approach. Okay, so that is when you do step 5, step 3, and step 5. Now, when you are doing step 3 and 4, step 3, if number 1 is not greater than number 2, then it moves towards the left-hand side, which is the null part, and then checks for number 2, which is greater than number 1, with that of number 3. So is 2 greater than number 3? If it is yes, then it will print out what? Number 2. But if number 2 is not greater than number 3, it goes all the way down here to print what? Number 3 as the greatest. Then eventually it ends the entire algorithm. So that is how this algorithm also works. And then finally, there's another approach to this. So let's go down here. Look at this approach. So it says here that it will first introduce another variable. In this particular algorithm, it's introducing a variable, okay, which is called big, and assign the first value A. So now the input in this scenario is using A, B, C as the input. It's assigning the first variable and saying that A should be the big variable. Then now it compares A to B, that's the big to B and the big to C. So if the big variable, which is A, is less than B, it will print out B. Then the next one, if A, which is the big variable, is less than C, it will print out C as the biggest. Then if none of those conditions are correct or are false, are true, if none of them are true, then it prints out big, which is A, as the output. So with this problem, we have seen what 2 approaches to handling it. And this is the flow chart for those 2 approaches. So now let's come to our document, and then we'll write some back to our chapter 6. Then we'll write some program on it. and I'll give you the opportunity to ask your question. So, Rosemary, let's stay on hold. All right, so okay. So what are control structures? Basically, they show you the flow of data or information in your program, how your program will run. So we've been talking about the branching control structure. So this one's the execute a statement if the condition is met. We've talked about these operators already from the algorithm lecture, so I'll not spend much time on it. So in C++, how do you write these control structures? That's the branching control structures. We've seen it from the point of an algorithm. We've seen how you can represent that when you are doing your flowchart. Okay. Now, in your C++ program, how does it work? So this is the if block. Okay, the if conditional block. As you can see here, we have your if, which is a keyword, and then you introduce your bracket, and then you put your condition in here. So the condition, for instance, number 1 greater than number 2, okay, is a condition. So if this condition is true, then what? It will execute the statement in there. Okay, so that's the if. So this is another way you can write the if block. Now you only write it this way if your statement, you have only one statement. Okay, so read this here carefully. It tells you what it means. You only write it in this form if you have only one statement to execute. Okay, but if you have more than one statement to execute, then you need to introduce your curly bracket and then put the statement in there. Okay, so that's the if block. Then we have the if else, the if else block, if else. So the if else, you have your if condition, your if keyword, introduce your condition. Okay, so let's say it's A greater than or equal to B. Okay, if this statement here is true, if it is true, then it will execute, if the condition is true, it will execute the statement here, statement 1 and statement A2. However, if it is false, now note, when the condition is false, when this condition here is false, that means that A is not greater than or equal to B. If it is false, it will execute the else. Now take note, with the else, we do not put a condition here. Okay, you don't put a condition here. All right, so like I was saying, if the condition is false, okay, that is when you use the else. If this condition happens to be false, it executes the else, okay? So you do not put any condition in front of the else. No condition here, no condition in front of the else. Please take note of that. Okay. However, the else will execute statement if the initial condition is false to execute this statement. Okay, so that's the else, if else block. Then we have the where you have multiple conditions. Okay, so there are times where you would have multiple conditions. Okay. A typical example is when you are looking at a problem which has to do with grading. Okay, so you have multiple conditions. So a problem which has to do with grading. So in that scenario, maybe you first take maybe the exam score of the person, the marks the person had. Let's say that marks is equal to X. Okay. So if X falls between the range of, let's say, ATU's grading system, we'll say from 85 to 100, the person deserves A. If X falls between, A plus, if X falls between 80 to 84, the person will be given A. They will be awarded A. If it's from 75 to 79, the person will be awarded B plus A. So this continues till the person is scoring below 50. The person is scoring below 50, that is an F. Okay. So you can see from this scenario that, or from this problem, that we have different conditions. This is the first condition. So your value, your marks in exams should be 8. If you are getting 85 and above, then it means that you are scoring A plus. That's the first condition. Then there's another condition here, which is saying that 80 to 84. Okay. Another condition here. Okay, and this condition will continue until you get to the last condition, where if the exam score is below 50. Okay. Now, how do you use the if here? So the first condition will be an if, okay, which is this condition. Now, the subsequent conditions that will come, whether 2 or more conditions, what will happen is that you use else if for the subsequent ones. Okay. So when you get here, you do else if. Else if. Okay. Until the last condition, we just put the else. Okay. So maybe in this context, we can put else because the person's marks, they made a mistake with the marks. The marks was supposed to be from 0 to 100. Okay, and they are entering maybe 101. The total marks they entered, instead of maybe 10, they entered 101. So 101, you say, we can put a statement here to say that 101 doesn't fall within that range. Okay, so that would be the else statement. So this is another condition where you can use the if-else statement. Okay. Now let's look at the last of the conditional branching example, and then we'll look at the C++. We'll go into the Dev C++ to try an example. Now, the branching or conditional statement, apart from the if-else statements, we have what we also call the switch case. Okay, so the switch case is another conditional structure. Now, this may or may not execute certain statements. Okay. Now it has a very peculiar behavior, very unique behavior. How does it work? So first you have your keyword, the switch keyword. Okay, the switch keyword. Now the switch keyword comes with an expression. Okay, an expression. So it could be any expression at all. Now, if the case, then we have another keyword here, which is a case. Now, the case takes a constant value. Okay, so if the expression value is the same as the constant value, okay, if it's the same as a constant value, then it will execute the statement. For instance, here we say constant 1. And let's say our expression, we say, for instance, int x. We declare int x. Then in our expression, we say that x is equal to 1. Okay. Then in our case, we say case 1. Then when we come to the next case here, we say 2. When we come to the next one, then the last one is default. Okay. So what we are trying to say is that if our x here, okay, the value of x is equal to the case. So in this case, x is 1, which is equal to case 1. Then it will execute this statement. Okay. But if x is 2, then it will check the first case. Here, case 1. 1 is not the same as the expression. So it will skip this and come to the next case, which is 2. Okay, case 2. Is 2 the same? Is the value 2 here the same as the expression here, which is x is equal to 2? If it's the same, then it will execute this statement. Okay, then we have another keyword here, break. So there's keyword break, continue. You can read on them, what they do in your control structures. Then we have the last one, the last keyword here, which is the default keyword. Now the default keyword works just like the else. Okay, so with the default keyword, if none of the cases, okay, or the expressions agree with the constant, if none of them, okay, so for instance, if for instance we say x is equal to 5, and you can see that we have only 2 cases here, case 1 and case 2. Okay, so because we don't have 5 cases, it doesn't meet this, it doesn't meet case 2 either. So what will it do? It will print out what? The default. That is to mean that none of the cases, constant of the cases were satisfied. So it will print the default case. Okay, so that's how the switch case works. So any question so far before we look at an example from our lecture notes? Any question? If you have a question, you can raise your hand. Yes, Christian.
Okay. Sir, good evening. Sir, I think someone told me that the default thing over there, when you don't bring it, someone can hack your code or something. Is it true?
What I don't know the basis of your conversation with the person, but it's someone can hack your code. Is that what you said?
Yes.
I don't know the context with which the person
Okay, so
is
we
saying that,
we were
but
creating I think a calculator that will be
okay.
calculating everything. Then he said when you don't bring the default statement over there, someone can hack it. When the person doesn't bring, maybe you see when you're doing the calculator, you have plus, minus, modulo, and everything inside. But the person can bring maybe 1Z5, then it will print out your code.
For the context of what we are doing, I would rather we don't use the statement hack. Okay.
All right.
In terms of programming, we would say that you are committing an error, which we will term runtime error. Next semester, we will look at those types of error and how we can handle them. Okay, we call it an exception. Okay, it's called a runtime error. Your program will run all right, everything will work all right, but people would you would experience certain kind of error which you are not supposed to experience within the code. Okay, so I get it from what the person is saying that someone can hack it. Not necessarily that, but it will end up in an error. It will be an error from the part of the program. Okay, so if you don't bring it, a typical example is maybe we want to grade a student, okay, and you know that a student's mark can be within from 0 to 100 percentage wise. Okay, so if someone mistakenly enters a value of 101, which doesn't fall within the range of 100%, okay, if you don't write the program well, especially without introducing the default, what will happen is that the person can end up scoring an A, which is the fault of the program. Or depending on how you write the program, the person will, the user of the program will get an error message. Christian, are you following?
Yes, sir.
Okay. So these are statements that are used to end this, the switch case, in this case, the default, and then even the if else statement. Yes, there are statements that goes with only if, without any else. And then there are other statements that you need to bring, depending on the problem, you need to bring the else. If you don't do it that way, people can just override on your mistake as a programmer and then mess up the functionality of the program you've written. All right, Philip, your hand is up.
Yes, sir. Please, I didn't get the case constant was. I wanted you to explain.
The feedback. Do you have another person listening, or you have another account?
Yes, please.
Mute it or turn off the audio.
Okay.
It's as if you want to listen to yourself whilst you are speaking. Yes, Philip,
Sorry.
let's go. Yeah.
Please, I wanted to understand the case constant well. I didn't get it well, so I wanted you to explain it for me a bit.
Maybe when we try an example on it, you understand.
Okay.
It. So we'll look at
Thank you.
the example. Yeah.
All right. Thank you.
Rosemary, your hand was up earlier. If you can ask your question. Yes.
So, please, I don't understand the algorithm. The third one, the one with the three decisions.
Oh, the three decisions.
Yes, please.
Yeah, so imagine you have three people standing. You want to tell who is the tallest. The first person, second person, third person. You want to tell who is the tallest. Okay. So you first take the measurement of the first person and the second person. If the first person is taller than the second person, it means now the second person is now short. That second person, you can't even compare him with the third person because you want who is taller. So automatically the second person is out of the scenario. And now you take that first person who is taller than the second person and compare the height of the first and that of the second and that of the third person. Okay. Then once you get who is taller, you now tell that okay, the second person, the first person is taller, or the third person is taller. That's what the algorithm is about.
Okay, so you see with the two,
Pardon?
with the two, you see with the two, the first one that you solved the task before,
Yes.
the decision you brought only two, but then when it came to the three, you brought the decision.
Yes.
So that one,
Because yes, I'm listening.
okay. So like when it comes to an exam, how are we going to do it? If we should bring two, are we right? Or
Ideally, if you have two people, you want to tell who is taller than the other. What would you do? If you have two people, what would you do?
you just compare the two of them. Yeah.
The height of the two of them. So
Yes,
that
and
is
then
just one time condition. So there are only two people. So we just compare it once and then that is it. Okay. Now you have three people. So how do you do that comparison? You have three people. How do you do that comparison? So this is what I've explained. Now another approach is saying that, let's say that, okay, you have three people. You have Joseph, you have Rosemary, you have Abdul Majid. Then we are saying that, okay, let's assume that Rosemary is tall, is the tallest. So we are putting Rosemary aside. Then, so in this case, Rosemary is big, is the big here. Then I will say that let's compare Joseph to Rosemary and let's compare Abdul Majid also to Rosemary. So we compare Joseph to Rosemary, realize that no, Rosemary is big. So Joseph is short. Then now we take Abdul Majid and compare Abdul Majid to Rosemary. That one to realize that Rosemary is still big. So what do? We say that oh, Rosemary is the tallest or is the biggest. Okay. So all you need to know is the approach, how you go about it. As for writing the algorithm, you have different ways you can write it. Okay. But how do you tell whether someone is taller than someone? I can increase the number to 4. You have 4 people. How do you tell whether who is the tallest? Okay. So someone can say that, okay, if I have 4 people, I'll divide them into 2. I'll compare the first 2, and then I'll compare the second, the third, and the fourth person. So if I compare the first and second person, I get who is the tallest. And I'll come and compare the third and fourth person, get who is the tallest. Then the 2 tallest, I'll come and compare them again to get finally who is the tallest. It's like we are playing football match, play semi-final. Then after that, you come and take the final for those who won the semi-finals. Then they play the final and then you get your winner. Okay. So if the number of people you are comparing, who is the largest, who is the biggest, who is faster, who is this, just analyze it from this perspective and then you can now write your algorithm. Exactly.
yes, thank you.
Okay, welcome. So let's take Benedict's last question and then we move to Dev C++ and write some 2 programs on the control. The conditional control structure. Benedict, your hand is up. Okay, the hand is down. So let's look at an example. So the handout has some examples there. Let me just go through them. So if we look at the if-else statement, there is an example 5.1. Okay, you have 2 numbers. Tell which one is greater. This is simple. Then the switch case also, there's an example here. So let's look at this example. It says we want to check whether a number is divisible by 5 or not. Okay, whether a number is divisible by 5 or not. So that's one example. Here too, you want to check the age range of someone. Okay, whether the person falls within the age range of 0 to 12. If it's 0 to 12, the person is a kid. If it's 13 to 19, the person is a teenager. If it's from 20 to 35, the person is a youth. If it's from 36 upwards, the person is an adult. Okay, so this program is doing that. Okay, so let's look at that and then we'll come to the switch case example. Okay. But I want you to try this example. However, I'm going to use the example. I'm going to write a program on the example that has to do with the algorithm we saw. Okay, so that algorithm was looking at the largest, okay, or the smallest of 2 numbers. Or let's do the largest of 2 numbers so that you can do. You're not going to say that every time the lecturer is doing the simple example and then he's giving the difficult one to us in the exam. So let me do the difficult one so that you go and do the ones in the handout. Okay. So we'll look at the example 9. That's algorithm 9, which has to do with the largest of 3 numbers. Okay, the largest of 3 numbers. So I'll put that here, the largest of 3 numbers. So we start our code with our hash include. Our hash include IOStream. Then using namespace std, then our int main. By now, you should know how to write the program to this point. Ali, you should know how to write this. This is a default syntax we use all the time. Okay, so the next thing is how now we are coming to implement our algorithm inside the main function. We're now coming to implement our algorithm. So for our algorithm, it said we should what? First enter the 3 numbers. Okay, so what we'll do is we'll first declare the 3 numbers. So I'll use A, B, and C for the 3 numbers. Okay, A, B, and C. So we'll say int, you can use float or whichever numeric data type you want. So int A, B, and C. Okay, so I've declared the 3 variables A, B, and C. Then we want to prompt the person to enter value for A, B, and C. So we say enter so this comment will be to enter values of A, B, and C.
Sir, please, can we use character?
Who is asking the question? So we say C out. C out. We say enter the first number. Hello, can you all follow?
Yes, sir.
No. So they said enter the first number. So I'll use C in and then A. A is the first number to accept the value for the first number. So I'm going to copy this, and then paste it twice because we have three numbers, A, B, C, and I'm going to edit them. So this one, I'll say second, enter second number. Second number, we use variable B, and then enter third number. Third number, we use variable C. Let's use the C out here. C out, say, enter. All right. So now we have to make the decision. Okay. So the next thing is to make the decision based on the condition. So we said first, we'll compare. Let me go all the way there. That first, if number one is greater than number what? 2. Okay. If number one is greater than 2. So we say if. So if A, which is the first number, we want the largest. So if A is greater than B, then what do we say? We put a statement there. C out. C out. I'll say A, comma. We know we put the value for A, then we'll say is the largest. End line. Okay. So let me just do a return of this, return 0. And then let's run this code. Let's compile and run this code and see what will happen. So I'll save it. So this example, let me say 4.5. Wait, this example 6. So 6 point, let me say 1. It's 6_1. So you can see here, it says enter the first number. So if I enter 4, I enter 2, I enter 4 again. What does it give us? A, which is 4, is the largest. So that's our output, because it's comparing the first one, which is 4. Okay, comparing 4, which is A. Let me write that clearly. This is A. A is 4, B, and then C. Okay. So it compares A and B. Is A greater than B? That is here. So we know our A to be what? 4, and our B to be 2. So this will give us true. Okay. So if it is true, then it's saying that what? A, which is 4, is the largest, as we can see from here. Okay. So that's the first instance. This is the first instance. Now we've only compared A and B. We've not compared C to it. Okay. For instance, if C were to be 5 and we are comparing the 3 numbers, we all know that what 5 should be the largest. So we'll go back to our code and then add the comparison for C to it. Okay. So in this context, we are going to do what is called a nested if statement, or a nested if else statement. Okay, nested because you would have an if statement within another if statement. Okay, so to go on with that, let me introduce the curly bracket and then paste this in it, because we are not going to have only one statement. We are going to have another if else statement in it. So we are saying that if A is greater than B, then we will now have to compare A and then we now have to compare A
And C.
and then C. Okay, we now have to compare A and C. So we will say, before we will say A is the largest, we want to compare A and C. So we will say that if A is what? Greater than C. So you can see that within my if A is greater than B, I'm inside it. I'm inside this if. Okay, and comparing again. So I'll say that if A is greater than C, then we'll say that what? We should print, let me use a curly bracket so that you appreciate what is happening. We should print A is the largest. So in this context, it means that A is greater than B and A is also greater than C. So A is greater than them all. Okay, so I'll compile and run again. Let's see what output we get. And then we'll come and do the B and the C parts. So we enter A as 4, B, which is the second number, as 2, and then C as 5. Okay, so you can see here clearly that by observation, we can see that A is greater than B, which is 4 is greater than this, that's the 2, but 5 or A greater than C is false. Why? Because C is what? 5. Okay. So because this is false, it didn't print out this statement for us. So you can see that it didn't print out anything. It left us hanging because we've not indicated a situation where if C is greater than this, is greater than our A. Okay. So in this scenario, A is not greater than, A is greater than B, is greater than B. That is true. That is true. However, A is not greater than C. Okay. So let's go back and add the additional conditions to our program. Okay. So we'll come here and then we'll say else, then I introduce my curly bracket. So inside the else, we are going to put the else. So this else has to do with the C here, not the B. Okay, because we are inside the first condition. Okay, so this else here has to do with this condition here, the second condition here. So else, we'll say that C is greater than, or C is the largest. Okay, then we now move out of this if. So look at the breaks here. This break here is for the if. Okay, now this here is the nested loop. So you can see that this if here is inside this. Okay, it's nested. Likewise, the else is also in this. So we are going to come out of this, the first if, sorry, my mouse is misbehaving. So we are going to come out of this and say here, else. Okay. Now this else here will mean that B, okay, or we might want to do the same for B and C. Okay. We might want to do the same for B and C. So we'll say maybe else I want to introduce, okay, so let's say else if. I want to introduce another scenario. So let's say else if A, sorry, else if, not if else. Else if let's make it else. Then I'll introduce the next scenario. So else we'll say, else meaning that B is greater. So else, we'll come and put another if here and say if B, okay, is greater than C, then we should output B as the largest. Okay, so B will be the largest. Else C is the largest. Else C is the largest. Okay, so let's run the code again and let's see how expected. Okay, Gloral declaration. Okay. So because we introduced a curly bracket here, we didn't close this curly bracket. Okay, so we are supposed to close it before we come to the else. So I'll put it here. And then even after this, okay, this is here. So please take note. Sometimes when you are doing nested statement, the curly brackets are important. So you realize that when I click this, it's showing me where it's ending. When I click this, it has to show me the closing. When I click this, it has to show me the end. This is the end. This has the end here. And then when you are open, I close it here. Okay, so please take note of your use of the curly brackets. Okay, return expected an ID before the return. Okay. This is here. Sorry. I think I've introduced another bracket, which is not supposed to. So, all right. So please, whilst you are doing this, take note of your curly brackets, okay? Else you might end up having the error I'm getting. All right, so let's look at it again. So the first one, we have 4 as the first number. Second number, we have 2. Third number, we have 5. So what is that giving us? It's telling us that what? C is what? The largest, which is true. Okay. Now, how come it's telling us C is the largest? First, just a minute. Mouse is need to change the battery. All right, so let's go on. So the first comparison is happening here, where we have A, which is 4. A is 4, and then B is what? 2. A is 4, and B is 2. Okay, so in this case, this will be true because A is greater than B. This will be true. Okay. So if this is true, that means that we can now execute the statement in the if block. Okay. We can now execute the statement here. So this is the if block. If I click here, you can now execute the statement in here. Okay. So if this one is true, it means that this part is out. The false part will be out, will not be executed. Okay. So what happens? So if 4 is greater than 2, A is greater than B, that means A is the largest. So now we come and compare A and then C. So A is 4, and then C is 5. A is 4, and then C is 5. Okay, so we compare. Is A greater than C? This will give us false. This will give us false. So if it is false, that means it will skip this statement here. Skip this statement here. Because it's false, it will come all the way to the else. Come all the way to the else, and then come and print C, which is what? 5. Come and print C, which is 5, is the largest, as we have here. Are you following?
Yes, sir.
Yes, sir.
So let's run the code again and look at another scenario. My mouse is misbehaving, so not able to move fast. So let's run it again and change the values for A and B and see what we'll get. So enter the first number. This time I'll say A is 2. I'll say B is 5. Then C, the third number, is 4. Now what is it saying? It says what? B is the largest. How come we are getting B at the largest? Let's go through it together. So we have A as 2. A as 2. Then B as 5. Okay. And we know A greater than B will be false. A greater than B will be false. So A greater than B is going to be false, as we can see here. False. Okay. Now, if it's false, it means that the whole of this if statement will not be executed. Okay. Rather, it will come and execute the else. because it's false. So if it's false, now we come to the else, and the else is saying if B, which is 5, is greater than C, which is 4, okay, then it should print out what? B is the largest. So this B is greater than C, so it's true. So because it is true, it's going to print out B, and our B here is 5. So B, 5, is the largest, as you can see from our output here. Okay, so you realize that because this is true, it doesn't even execute the false, the else part again. Are we all here?
Yes, sir.
Okay, so this is the example.
Yes, sir.
This is the example on the to find the largest of 3 numbers. Okay, and like I said with the algorithm, this is not the only way. There are other ways you can write it to perform the task. Okay, but it should perform the task. Let me put it that way. There are other ways you can do it. Like you saw in the algorithm part, there are 2 algorithms there. Okay, so what we've done over here is to implement the first algorithm which we saw. Any question before we look at the switch case example? Unfortunately, because of time, we might have to only do the switch case. And we'll see if we can schedule another meeting in the course of the week. Okay, so that we look at the loops, because we have limited time and we need to look at all these topics. So, any question? If there's no question, let's look at the example on the switch case. So let's look at the switch case example. Yes, Paul, your hand is up.
Sir, please, good evening.
Good evening.
Thank you for the opportunity. My first question is that, you see, when we were comparing the A and B, and we said the A is the largest in the code.
Yes.
Please, since we are not at the final stage for A to be the largest among the 3 variables, please, can we say A is the larger for now? Then when we get to the part that we are comparing A to C, then when we get the largest number, we say that this variable is the largest.
Okay, that is also, like I said, it's up to you, the program. Okay, so
okay.
in your scenario, if I get you right, when you do the first comparison, like A and B, then we will come and output that A is larger, but not the largest, right?
Yes,
We'll
please.
come and say
yes,
A
please.
is larger. Then we will now come and do A and C. Then after doing that, we'll say that then if we do A and C and we think A is still larger than C, then we will now come and say A is the largest.
Yes, please. That is my question.
Yeah, you can do it that way.
Oh, okay, please. Thank you very much.
Okay, you're welcome. Like I said, it's an algorithm. Okay, so it's not like given a problem of finding the largest of 3 numbers. I'm not saying that what the code I've written here, that is the only code that can solve it. Okay, there are so many ways you can write this code to solve this problem. So like the example Paul just gave can be someone else's approach to solving the problem. Okay, once it's giving us the correct answer that if it's A is the largest and it's A is the largest, we are good to go. Okay, we are good to go. All right, so let's look at the next example, which has to do with the switch case and see how it works. So I'd want you to try this example I made a mistake with the numbering. This is supposed to be 6.5 because we are in chapter 6. So this is saying that check if a character is a vowel or not. And we know what vowels are. A is a vowel, E is a vowel, I, A, E, I, O, U are vowels. Okay. And if it's a character, we've learned how to represent characters in programming. Okay, so the vowels are A, E, I, O, and U. Okay. Now we said characters are case sensitive. Okay, or letters, the alphabets, they are case sensitive. So you do for A and you do for small a, capital I as characters, capital O, capital U. So here you do the comparison, and you remember we mentioned this symbol. Who can tell me what symbol this is? It's a logical operator. Yes, that's the OR symbol. The OR operator. Okay, and we know how the OR operator works. The OR operator works if at least one of your statements is true. So we have, if one of your condition is true, okay, your statement. So we have one statement here, we have another expression here, we have another expression here, another expression, another expression. So we are saying that enter an alphabet and the variable name is alpha. Okay, so whether the alphabet you entered is small a, capital A, small b, small e, small I, small o, small or uppercase A, uppercase E, uppercase I, O, U, if it's any of them. So we are using OR in this context because at least you are entering only one alphabet. So at least one of the alphabets should be true. So if here I enter capital A, what will happen is that it will compare. Is capital A equal to A equal to the letter small a? No, this is false. Okay, so this is false. This will be false. Then it will come here and compare to E. Okay, it's also false. To I is also false. O is also false. U is also false. But capital A is the same as A, the uppercase A. Okay, so what happens? This will become true. Okay, so we are using the OR here because at least one of them should be true. If one is true and the others are false, because we are using the OR, the expression is true. Okay, so if the expression is true, it's saying that case one meaning that true is the same as one, okay, or yes. Okay, false is no. So it means that the entire expression from alpha small a to alpha capital U, the entire expression there inside the switch is true. Okay, so if it is true, then that is what? One. So it will execute A. The A that we entered here is a vowel. Okay, but if we enter any letter which is not a vowel, for instance, the letter Q, Q is not a vowel. Okay, so it will not satisfy any of these conditions we've given here. Okay, meaning that Q will, or it will tell us what Q is not a vowel. Okay, so try this example out, try it out, and let's try. We will implement this one right now, which is a weekend example. Okay, this example. Okay, so let's move to our Dev C++ and try it. We have like 10 minutes to end the class. So in this example, we want to tell the day of the week. We want to tell the day of the week. So I'll put a comment here. Say weekend example. Weekend or day of the week. So start with the hash include IOStream. Then using namespace, std, int main. Okay, so that we implement it. So we are going to say that, okay, let's introduce a variable. So let's say int, let me say day. So we want to say that the days of the week, we want to introduce numbers for it. So if it's a Monday, you say 1, Monday, 2, Tuesday, 3, Wednesday, all the way to 7, which is Sunday. Which is Sunday. So that's what we want to do. So the day, the variable day we are using here is just to show the number. That's why we are using it. Okay. Then we'll say cout, and we say enter the number of days. Number of the day. Okay, of the day, or number of days. Let me just say number of days. So you are entering from 1 to 7. Then we use the cin, and then we accept the value for the day. Let me use cout here and put end line here. Okay. So now we want to implement the switch case. Switch case to make the decision for decision making. Okay. So we are saying that if the person enters 1, it means it should tell the person it's Monday. If the person enters 7, it should tell the person it's Sunday. Okay. So how does the switch case work? First, you use the keyword switch, then into brackets. Now this bracket is going to take the expression. Okay, so in this context, we put here day. And then we come to the case. So we introduce our curly bracket. And inside it, we'll come to the case. So I'll say case 1, colon. Okay, so case 1, if it's case 1, it should print out it's Monday. Then say break. Okay. So I'll copy this case and paste. So we have 7 days, right? So I have to paste it to match the number of days. But I'm going to introduce you to something. quickly. Okay, so we'll say this to 2. Then we'll say Tuesday. Then this to 3. I'll edit it to Wednesday. Let me just do a shortcut. Four. So we say Thursday. And 5 Friday. All right, so I want to introduce you to something here quickly. So I'm going to paste another one here. However, I'm going to omit the statement within that case. Okay. So here, I'm putting here. So from case 5, we move to case 6, then case 7. So here, I'll say that it's weekend. It's weekend. So this is a bit different from what is in your lecture notes. Okay, just to explain something to you. And then finally, I said we'll end with default. Okay, so with the default, I'm going to put here, let's say, C out. So we and say you entered the wrong day. Okay. So you are telling the person to enter from any number from 1 to 7. Then the person goes to enter 8. Okay, so the default, we just tell the person you entered the wrong day. So let's end with our return 0. And then compile and run the code. So I'll save this as example 6_2 at CPP.
Sir, please, could you zoom out for us a little bit?
Pardon?
Could
Who
you
is
like
speaking?
zoom it out a little bit?
Zoom what?
The code, because we can't see from the beginning, the top.
Oh, it's in your lecture note. So the only change I've made is this part. You see it in your lecture note. This is the only part I've added. So it's in your lecture note. So just refer to it.
I appreciate it.
So let's compile the code and run. So as you can see, this the output. Okay, so it's prompting us to enter a day. So let's start with the default one. So I enter 8. What does it say? It says that what? We've entered the wrong date, the wrong day. Okay, why? Because the cases we gave here, none of them were satisfied. Okay, were met. So it's telling us we entered the wrong date. Now, what is happening? So I was saying that you enter the day. So it said int day, we declare it. Now it prompts you to enter the day. So it takes the value. So at this instance, we entered what? 8. So that 8 comes in here. Okay, under the switch. That's the day. So the day is representing the value 8 that was entered. Okay, so it's comparing the 8 to all the cases. So the first case, 1, is 8 equals to 1. Is your day equal to 1? That's what is happening. If it is false, then it moves to the next case. Compares. Okay, so it goes through all the cases and realize that none of the case has a value of 8. So what does it do? Automatically, it prints out the default, which is what? You entered. Okay, sorry, you entered the wrong day. Okay, you entered the wrong day. So let's run this again and let's look at the other scenarios in this example. All right, so enter a day. So let's enter 3. So what does it say? It says that it's Wednesday. Okay. Why? Because a day value here, which is 3, this is false. It's not the same as case 2, but it's rather what? Case 3. So it's telling us what? It's Wednesday. Are we all here?
Yeah.
So let's look at the last scenario, then you can ask your questions. So I run it again for the 3rd time. Right. So enter a number of the day. This time I'm going to enter 6. Okay. Now you can see from here that after case 6, we never introduce a statement. There's no statement here after case 6. Okay, and then we went straight towards case 7. And we said that case 7, which ideally case 7 should be what? A Sunday, and then case 6 should be a Saturday. Okay, so if I come back to my output and press enter, it says what? It's a weekend. But we all know that case 7 is supposed to what? Is the one printing, showing us the cout statement as weekend, not case 6. Okay, but this the unique thing happening here when it comes to switch cases. Okay, if you introduce a case and there's no statement there, like we can see in case 6, what happens is that it treats case 6 and the next case, which is case 7, as the same. Okay, so whether you enter 6 or 7 as your value you are supposed to enter here, it will give you weekend. You get it? So anytime you write your case and you don't put a statement in that particular case, it treats that case as equal, okay, to the next case. So it's going to now give a statement within the next case as that of that case and then the previous one. Okay, so that is switch case for you. I'm done with today's lecture. I'll take 5 questions. So if you have a question, you can raise your hand. All right, so Paul, your hand has been up for a long time. You've already asked the question. I don't know if you have another question.
Yes, please, sir. I have
Okay.
another question.
All right.
Sir, please, the question says, in terms of using the switch, can we declare the switches after the int main?
Okay. Can you do what?
Can we bring the switch
As in this
after
switch?
Yes, please.
After what? Int main?
Yes. Or
Why?
after the int day.
Why would you bring it before the int day?
Will it work?
Try it yourself and
Oh, okay.
yeah.
Yes,
Logically,
sir.
look at it logically. As a programmer, what do you think will happen? Without you trying it, look at it. What do you think will happen? Anyone can attempt it. He's saying that we should bring the switch day before we declare the int. So we should move this here. What do you think will happen? If you know you can speak.
I think you get an error.
Yes, you get an error, but what will happen?
The code will not be
Sir,
able
I
to.
think it's going to treat everything. It's going to
Hello,
treat
sir.
everything as space.
Yes,
Hello.
Christian. Yeah.
Sir, what
Yeah, sir,
I
it's going to
think
treat everything as space.
Christian.
Sir, when you bring it, they're going to treat everything as space.
No.
Hello, sir.
Yes,
Sir,
wisdom.
please, will it
Let's
So
listen to wisdom.
int main defines the class. So without that, bringing the switch before the class would be a problem because it's inside this class that we are able to define.
Let me correct you before. Wait. Wisdom just said something. Let me correct him. Okay. So wisdom, we are not talking about class here. We have not started the concept of classes. Okay. So the int day here is not a class. We've just declared the variable day. Okay, so using the term class is not the right thing. It's not the right term to use.
Okay, sir.
Okay, so what you are saying makes sense. So please correct yourself, come back and say the right thing. Instead of using the word class, you are on the right track. But the use of the word class. So just wisdom, are you with us?
Yes, I'm here.
Yeah. So say whatever you are saying without the use of the word class.
Okay, so int main is supposed to define whatever we are doing in here. And then if you haven't defined what switch is, and then you are trying to bring that before defining it, it doesn't make the code right.
Let me correct you.
Meaning, does it mean that,
let
sir,
me
please, does it mean
Paul, just hold on. Paul, just hold on. Okay. So
Okay,
what
sir.
it's trying to say is that we said switch day, right? Emphasis on day. Emphasis on the expression inside the switch. That's the day. Okay. So we've not defined what the day is. So if you end up bringing the switch before the int day, it's like you are using a statement and you've not defined or you are using an expression and you've not actually defined what the expression is, and you've gone ahead to use it, so it will give you an error. So you are supposed to define the expression the expression inside your switch, which is the day. You are supposed to define it here or declare it here by using the int day before we use the switch. You get it? Paul,
Please.
Yes, please.
you get it? You don't just,
Yes.
if you want to start by using the switch day, then it means that you are just, how do we say it? You are, let me look for the right word. You are just giving the switch value here, which is a day, a constant value. If you end up giving it a constant value, then why not? For instance, if I want to comment all this and I say comment all this, so that means after my int main, immediately I'm starting with a day. If I run this, it will give me an error. Why? Because I've not declared day in the scope. It said day was not declared in the scope. I've not defined this day. So if I will start by using this, it will give me an error. Why? Because I've not declared it. I've not defined it before I'm using it. Okay, before using it. Rather, if I use a constant value, let's say, instead of the day, I use a constant value, say, constant value, let's say 7. Okay, and I run this, it will compare the 7 with what? The case 7. You get it? It will compare it with case 7 and tell us what it is weekend. But ideally, what we want to do is that we want to prompt the person to enter the day, and then to tell us what day it is, the number, and then tell us what day it is. You get it? You get it?
Yes, sir. Please. Thank you very much.
Okay, you're welcome. Gaffer.
Sir,
Gaffer.
please, I want to.
Hello, are you Gaffer? Mano, are you Gaffer? It's in order
No, sir,
of
but
those who have raised their hands. So let me.
Yes, sir, but
listen
please,
to
I
Gaffer.
wanted to talk about.
Please, we've exceeded our time, so let me go with the order in which you realize that at the point you raise your hand, I won't get to you, so you want to pause in your question. Gaffer, please, let's go.
Yes, sir. Thank you. Please, I wanted to ask, without bringing the default line, when you enter a wrong day, what will happen?
What do you think will happen if I take this default line out? What do you think will happen? Go and try it out, Gaffer.
Okay, sir.
When you watch the video and you're practicing, you can try it out.
Okay. Thank you.
Ebenezer, you're welcome. Ebenezer, that's it.
Okay, sir. Thanks for this opportunity. I wanted to ask if from the code, if you run it and maybe you mistakenly entered 8, which is not part of the days.
Yes.
It will tell you maybe you entered the wrong day. Can you just add something like maybe an if like an else statement that it will just take you back to where you are supposed to enter the number again?
Okay, so that will lead us to the next topic, which is the loops. So it will repeat the code again. Instead of ending it for us, it will repeat it again or tell you to enter the correct number, right? Is that what you are saying?
Yes, sir.
Yes, so that will take us to our next topic, which is the loops.
Okay, sir.
All right. Yes, Frank. Yes, Frank, do you have a question? If Frank is not ready, let's go to, okay, Emmanuel Boating. Your hand is up.
Thank you,
I'll
sir.
ask your question, finally.
Yes, sir. Sir, please, when you were doing the other example,
Yes.
the else if, the one we
Yes.
used the else and if,
This one.
I saw we were, yes, sir. The nested if, I realized that you gave the conditions before the curly bracket, and then the statement came. But I don't know how to put it, but most of the times, other videos that I've seen, they didn't introduce these ones. They use the else if directly. So I was thinking, in those ways, are they all going to work, or
I've not
there's a
used
particular format?
else if here. So I'm not getting your question. I didn't use else if here. I've only used if and else. I've not used else if in this condition, these conditions.
Yes, sir. I get you, but there's a similar question, a similar
Okay.
thing that I was trying my hands on.
Okay, and
And
you
then
use
the
else
person,
if.
yeah, the person used else if.
Yes. So that's why I said after the example that there are so many ways you can address this particular question. Okay, so what I've showed you here is just one way. Someone can use else if to outline the various conditions. But in that scenario, it would not be nested like the way I've done it. The person's algorithm would be different from the algorithm I used. Okay. What I've done here has to do with the first algorithm we saw for the example. You know, there were two algorithms. So this is in line with the first algorithm, where you compare the first one. If it is, then you compare it with the second, the third number. So the person's video you watched might also be using a different algorithm, which is also solving the same problem. Exactly. Okay. All right. So Frank, your question, and then we call it a day. Okay, if Frank is not ready. All right, so we'll end the class here. I'll get in touch with your class reps and see if we can get another opportunity, maybe an hour, to look at the loops. Okay, it's very important. We need to look at it before our face-to-face meeting next week. Okay, like I said, there's a project on the LMS which I want us to look at. Okay, which has to do with function. Next week, when we meet face-to-face, I want us to look at functions. Okay, then after introducing you to functions, we'll take this project. So please download the project and look at it. The project will require the use of the control structures together with the conditional, together with the loops. Okay, so class reps on our page will discuss and find a day so that we can do some 1 hour for the loops. Look at some example of loops for like an hour. So that's next week. Look, move straight to the functions.
Okay, sir.
Okay, sir.
Sir.
So let's pray and Father, we thank you for another opportunity. Pray that all that we learn, pray for wisdom, understanding, clarity, attentiveness, that isn't how to go and practice. Understand it. One day. Enjoy the rest of the
Okay.
Okay.